Imagine standing before a mirror unlike any ever built by human hands. It doesn't simply reflect light. It bends time itself. It isn't a pane of glass but a vast, gleaming disk of gold, each segment polished and curved so precisely it can catch the faintest echoes of the beginning. You lean closer expecting your reflection, your room, your planet, but the surface doesn't show you. It shows a universe in its first heartbeat, when existence was still inventing its own rules. This isn't fantasy. This is the James Webb Space Telescope, humanity's most powerful eye turned toward the ancient past. Webb was crafted to peel back the layers of time, to reveal the moment when darkness became light, when the first stars ignited. But when it opened its golden eyes and stared deeper than any instrument before it, what stared back was not simplicity, not silence, but contradiction. Something that didn't fit anywhere in the story we had written for the cosmos. For decades, astronomers thought they knew the rhythm of the early universe. First came the Big Bang, not an explosion in space but an explosion of space itself. Then a long, silent darkness stretching hundreds of millions of years. Slowly, gravity gathered thin clouds of hydrogen and helium, the simplest elements, into the first stars. Those stars lived, died, scattered heavier elements into the void, and only then, after many cycles, did complex galaxies arise. The further back we looked, the simpler everything was supposed to become. Webb shattered that assumption. In a region of sky once believed almost empty, the telescope captured the light of a fully formed galaxy. Not a faint smear, not a fragile cluster of gas, but a vast, rotating spiral system with arms of starlight wrapped around a dense, glowing core. This was no cosmic infant wobbling in gravity's grip. This was a city of stars, already built, already thriving. And it wasn't alone. One after another, more galaxies emerged from the dark, each impossibly evolved for its age. Where scientists expected cosmic infancy, they found cosmic architecture. It was as if the universe's clock had skipped billions of years of slow growth and jumped straight to maturity. Then came the fingerprints of light, Webb's spectral data. Light split into its elemental colors told a story even stranger. These galaxies didn't just contain hydrogen and helium. They held oxygen, carbon, even iron, elements forged in the depths of massive stars. That cycle of birth, explosion, and enrichment should have taken eons. Yet here, less than 500 million years after the Big Bang, it had already happened many times over. The early universe wasn't crawling. It was sprinting, burning, collapsing, rebuilding at impossible speed. And deep within one of these galaxies lurked a monster. Not a fledgling black hole but a supermassive one, weighing 1 billion suns. By every model we have, such giants need billions of years to grow, feeding slowly on gas, dust, and stars. Yet here it was, shredding matter in the cosmic dawn. Either black holes formed differently than we thought, or our entire story of cosmic evolution is wrong. Webb's high-resolution images revealed yet another puzzle. The galaxies weren't scattered randomly like cosmic debris. Their shapes and distributions echoed a hidden geometry, spirals, ratios, and symmetries reminiscent of seashells, hurricanes, and living organisms. Coincidence? Or a deeper law of nature woven into spacetime itself? And in the dark between galaxies, Webb found faint traces of complex organic molecules, not frozen in comets, not bound to planets, but drifting freely across intergalactic space. These weren't simple gases. They were the chemical scaffolds of amino acids. Life's ingredients were not latecomers. They were present almost from the start, woven into the fabric of the cosmos like threads in an ancient tapestry. Then came the image that stopped even skeptics cold. 6 galaxies arranged like petals around a central mass, equidistant, rotating in eerie synchrony. Astronomers called it the cosmic flower. Lensing? Turbulence? An unknown force? No model yet explains its precision. Some whisper it could be a signal, a structure built not to be used but to be seen, waiting billions of years until an eye like Webb's existed to discover it. What the universe may be telling us, and perhaps the strangest suggestion of all, the one that keeps even seasoned scientists awake at night, is this. What if the very act of looking is changing what we see? On the tiniest scales, quantum physics already hints at this uncanny truth. Subatomic particles shift their behavior when measured, as though the universe is holding its breath, waiting for an observer before deciding how to appear. For decades, we've been told this was a quirk of the microscopic world, something confined to electrons and photons, too small to matter in the grand scheme of things. But what if it doesn't stop there? What if this principle echoes upward, through stars, through galaxies, through the very fabric of spacetime itself? When the James Webb Space Telescope opened its golden eyes, we expected clarity. We expected a silent museum of cosmic history, each galaxy a fossil frozen in light, each star a bead of ancient fire. Instead, what we found was stranger. Some of Webb's most sensitive images began to show anomalies, faint but persistent. Patterns that appear, vanish, or transform depending on when, and even how, the data are processed. Delicate filigrees of light in one frame dissolve in the next. Structures emerge only after repeated analysis, only to fade as if they were never there at all. At first, astronomers dismissed them as noise, quirks of a camera so sensitive it can catch a single photon crossing billions of light years. But the question lingers, what if it isn't noise? What if something in the very act of observation, our instruments, our algorithms, maybe even our consciousness itself, nudges the universe, and the universe nudges back? If this is true, then the story of astronomy changes. We are not merely spectators looking through a cosmic window. We are participants, co-authors, triggers. Our telescopes do not just record reality, they may help write it. Every photon captured, every spectrum analyzed, could be part of an unfolding dialogue between human curiosity and the cosmos itself. Because what Webb has uncovered is not just a story about stars, galaxies, and black holes. It is a story about reality itself, its fabric, its rules, its memory. Galaxies that seem too grown for their time. Chemistry too rich, too early. Black holes too massive to have formed so quickly. Patterns too precise to dismiss as random. And molecules, complex, almost biological, appearing in places and times where they shouldn't exist. The telescope hasn't simply shown us the unimaginable. It has forced us to imagine more. To question whether the universe is a static backdrop or an evolving conversation. A dialogue written in light, stretching across billions of years. Perhaps we haven't found the edge of the cosmos at all. Perhaps what we've uncovered is its memory. A memory etched so deeply it stretches beyond time as we understand it. A memory that reveals itself only when a species is bold enough to build a mirror of gold and dare to look inside. And maybe, just maybe, that memory has noticed us. Think about it. For most of history, the universe did not need to care whether a species on a tiny blue world existed. Yet with Webb, humanity has done something extraordinary. We built an instrument precise enough, patient enough, curious enough to awaken echoes woven into the very structure of space. What if the cosmos has been holding its secrets all along, not out of indifference, but as a kind of test? As if asking, will you build the eye to see me? Will you dare to look? And if you do, will you understand? The question is no longer, what did Webb see? It's, what does the universe want us to know? Because behind the light of distant galaxies, beyond the ratios and spectra, past the models and charts, there is a deeper mystery unfolding. one that touches not only our science, but our very sense of who we are. We set out to observe the cosmos. But perhaps, all along, the cosmos has been waiting, patiently, to observe us.